This is Polynomials Lesson 1 Part 2, just adding and subtracting polynomials. So example 1, 3x squared minus x plus 1 plus 4x squared plus 2x minus 5. Really nothing new here. Just clear the parentheses. There's nothing to clear, right? The plus doesn't mean we have to distribute anything. It's just, there's an understood 1 here, but it doesn't do anything. So we can basically just rewrite this without the parentheses. These parentheses often emerge in application problems where these actually used to be big fat letters, maybe revenue or cost or something like that. So now just combine your like terms. 3x squared and 4x squared is 7x squared, and then negative x plus 2x is plus x, and then a 1 and negative 5 is minus 4. The problem comes with subtraction. You have to remember that we have an understood negative 1 there. Right? So we have 4x cubed minus 2x squared minus 5, close parentheses, then minus, open parentheses, 3x cubed plus 5x squared plus 3x minus 2, understood negative 1. So that negative 1 will get distributed to each one of these terms in the parentheses. And so basically it just changes those signs. So we rewrite the first term, the first expression in parentheses, 4x cubed minus 2x squared minus 5, and then minus 3x cubed minus 5x squared minus 3x plus 2. Now it's just a combined like terms problem. Identify, I usually start with the highest degree term, so my x cubed terms can be combined, and then my x squared terms can be combined, and nothing with the x, but I can combine my constant term with negative 5 and a positive 2. So I get x cubed minus 7x squared minus 3x minus 3. Okay, try this one. Simplify 1/3 x squared minus 2/3 x plus 4, close parentheses, and then minus, open paren, 2/3 x squared plus 1/4 x minus 7. Pause the video here. I know we got fractions, but we can deal with them. Alright, welcome back. So, distribute the negative 1 through and clears parentheses. Now we need to identify our like terms, and just sort of don't look at the fractional part now, just look at our x squared terms. I can combine my x squared terms, right, and then I can combine my my x terms. I'll use underline for that. Maybe I won't. There we go. And I can combine my 7 and 4. Now I'm just going to rewrite those terms side by side. Just particularly fractions, that's going to make it easier on my mind. So if you need help with any of these calculations, you can use the calculator. Let's go back to the home screen. So 1/3 minus 2/3. Hopefully you can do this on a little calculator, but just to show you how to do it, 1/3 minus 2/3. And then press math frac, and that'll keep it in fraction form. We get negative 1/3. So it's going to be negative 1/3 x, and then this next one, negative 2/3 minus 1/4. So negative 2/3 minus 1/4, and then press math. If you, let's say we forget to press math frac, you press enter and oh man, I want that in fraction form. Just press math and then frac. It'll push that back into fraction form. So minus 11/12, and then it'll be 4 plus 7. You can do that plus 11. So negative 1/3 x squared minus 11/12 x plus 11. So even with fractions, we'll be okay. You can use the calculator to crunch these out. This is not a lesson on getting a common denominator. Just a couple applications. So we have a geometric application here. So find a polynomial for the shaded area of each figure, and I'm just going to give you one figure here. So area is pi r squared. So I want to find the area of the shaded part. How would I do that? Let's suppose I actually knew what this was, like if that r were 10. So suppose r were actually 10. What would you do to find the area of the shaded region? You could find the area of the big region. So I could say pi times 10 squared and subtract it from the area of the little hole, right? So I'd subtract pi times 4 squared. Well, I just made up that 10, so what am I going to use for the 10? Use the r. So the area is going to be pi r squared minus pi times 4 squared. And I can rewrite this as pi r squared minus, we often go ahead and crunch this 4 squared out to 16, and we'll often put that number to the left of pi. Wouldn't be wrong if you didn't, but it certainly looks a lot better. And that's fine. Next section we'll learn how to factor out the pi, but we'll leave it just like that for now. Pi r squared minus 16 pi. This is an expression that would give me the area, the shaded region, for any value of r. Another kind of example we'll look at is a business example. So we have the term profit. Profit is revenue less cost. So if I give you a cost function and a revenue function, we want to be able to find the profit function. This is used quite often in business applications. And then part B, let's use our profit function to determine the profit for selling 400 items. Okay, so again, our revenue, and there's our cost. Profit is revenue minus cost. So let's plug these in. So profit is revenue. I just substituted my revenue equation in for revenue and minus the cost equation. Distribute through. Collect some like terms. And definitely use your calculator for that if you need it. So my profit is negative 0.03 x squared minus 0.02. I'm just kind of writing these side by side. Again, this is an optional step. And now we can combine our like terms. So profit is negative 0.05 x squared plus 30x minus 1,000. And again, we got that from combining the like terms for the x squared term and for the x term there. Just making sure you see where those numbers are coming from. It does say to evaluate when we had 400. So what's our profit? So what is P of 400? Definitely a calculator problem. Let's pull it up. We'll go ahead and clear it out. And so we can say negative 0.05 parentheses 400 squared plus 30 times 400 minus 1,000. So the profit would be $3,000.